Okay, today we're going to look at hyperbolas. That was the final form of the conic that you saw in the first video that you watched. And a hyperbola really it's got two branches. It really looks like two parabolas. But the definition of a hyperbola is the set of all points, x, y, in a plane. The difference of whose distances from two fixed points called the foci is a positive constant. With an ellipse, it was the sum of two fixed the distances between the foci. But with the hyperbola, it's the difference of the distances from two fixed points. For instance, if our hyperbola looks something like this, our foci is going to be in between, and we're talking about, say we have a point here, x, y, and here's distance 1, and here's distance 2. d2 minus d1 is going to be a constant, a fixed constant. The absolute value of those differences is a constant, a fixed constant. So that's just part of the definition of a hyperbola. Now, we want to first look at the equation of a hyperbola whose center is at the origin, right? A hyperbola has vertices, it has foci. I've sort of sketched a graph here, but let me get a better graph of a hyperbola, maybe. Okay, let's say that we have, here's our axes, and we're going to start with our center at the origin. So let's say that this is a vertex and this is a vertex. And I'll go ahead and graph a hyperbola real quickly. Let's see, that's one focus, our foci. Here's another one. Okay, and our center here is at the origin. All right, the segment between the two vertices, if we say this is vertex 1 and vertex 2, that segment between those two vertices is called the transverse axis. All right, the transverse axis. And the length of the transverse axis in this case would be 2a. But let's go ahead and look at our two possibilities. Again, this is the standard equation of a hyperbola with the center at the origin. If we have a horizontal transverse axis, which is what I have drawn a graph of, a horizontal transverse axis, the equation is going to be x squared over a squared minus y squared over b squared equals 1. Our vertices will be at the point negative a0 and a0. Our foci will be negative c0 and c0. And this time c squared is a squared plus b squared. And we use b in helping us graph the hyperbola has asymptotes. And the asymptote, if the center is at the origin, the asymptote for a horizontal transverse axis is y equals plus or minus b over a. Remember that slope is change in y over change in x, so it's b over a. So if I knew that this is a, if this is b, B units, we're going to have B over A. Our asymptotes would look something like this. They form a little rectangle if you were to box them in. And they help us to know how narrow or how wide that hyperbola is going to be. So this is a horizontal transverse axis. Let's look at the equation for a vertical transverse axis. All right, if we have a vertical transverse axis, first let's look and see what that might look like. There's my X and Y axes. There, these are my vertices. This time it opens up and down instead of left and right. All right, this would be, well, we'll fill in those points in a minute. Okay, the focus, these are vertices. And the foci would be on the inside here. So if we want the equation for a vertical transverse axis, we have y squared first over a squared minus x squared over b squared equals 1. A squared always goes under the first term. Our vertices are going to be 0, negative a, and 0a. Our foci at 0, negative c, and 0c. C squared is again a squared plus b squared. And our asymptotes, I didn't put that that was an asymptote, I'll abbreviate. Our asymptote this time is going to be y equals plus or minus a over b x. I'm sorry, I didn't put the x there either because that's the equation of a line. So let's think about this. Okay, our vertices, we said are 0, negative a. And 0a. Our asymptote, our foci are 0, negative c, and 0c. And if we knew what b was, let's say this is b. If we graph those asymptotes, it's going to be y equals plus or minus a over b. So I go up a over b, down a over b. Same thing over here, down a over b. And so we can graph those asymptotes. And I really did not make my hyperbola wide enough. If I were going to graph it now, I would go towards those asymptotes. And I didn't get those even, but that's how you would use the asymptotes. But here are your formulas if the center is at the origin. That's all we're going to work with today. Next class, we'll look at the center being somewhere else. So let's look at some examples. Oops. Okay, so let's find the equation of the hyperbola. Its vertices are 0, negative 4, and 0, 4. The foci are 0, negative 6, and 0, 6. Always a good thing to, let's look at the graph, see whether we have a horizontal or vertical. I mean, you can tell by the points, but sometimes it's helpful to look. So if we have 0, negative 4, and 0, 4. We know we have a vertical transverse axis. So if it's a vertical transverse axis, the y squared is going to come first. So it's going to be y squared over something minus x squared over something equals 1. So let's see if we can figure out what A and B are. Well, the distance between the center and the vertex in this case is 4. So A is 4. Get back there. A is 4. C is 6. So we know that c squared equals a squared plus b squared, or 36 minus 16 equals b squared, so b squared is 20. So our equation is y squared over 16, which is a squared, minus x squared over 20 equals 1. If we wanted to find the, go ahead and graph this, our foci. Okay, let me add a couple more here, and a couple more here. Our foci are here and here. And our asymptotes are going to be y equals plus or minus a over b in this case. So that's going to be 4 over the square root of 20, or 2 square roots of 5. Or we could say that that's going to be 2 over the square root of 5. Square root of 5 is just a little bit more than 2. So if we were to draw our asymptotes from the center, we go up 2 and over a little bit more than 2. We would go down 2, a little bit more than 2. So we would have our asymptotes like this. And to graph it, we're going to approach those asymptotes. So this one is a little bit wider. Won't ever touch them, but approach them. All right, let's look at the equation. 9x squared minus 16y squared equals 144. And I want to find the vertices, the foci, the asymptote, and then I want to graph it. So to start with, we know that we need this to be equal to 1. So if I divide everything by 144, we're going to get x squared, 9 will go into 144 16 times, minus y squared, 16 goes into 144 9 times, equals 1. Okay, we know, we've already said the center is at the origin. It's at 0, 0. This is going to be a horizontal transverse axis because the x squared is first. So a squared is 16, so a is 4. B is 3. So c squared is 16 plus 9, which is 25. So C is 5. So if you don't want to remember formulas, we've already said that we have a horizontal transverse axis. If this is our center, we're going to have a vertex at 4, 0 and negative 4, 0. So we can go ahead and say what our vertices are. They are negative 4, 0 and 4, 0. Whenever you're graphing, you need to show your vertices, you need to show your foci, Our foci are going to be negative 5, 0, and 5, 0. So our foci, it's easy enough for me to get a different color. And then our asymptote, let me go back to white, it's going to be y equal plus or minus 3 over 4. Remember, it's change in y over change in x, so it's going to be, in this case, b over a, 3 over 4. So our asymptote is y equals plus or minus 3/4 x. So if I graph, let me change the color for this vertex. If I go up 3 and over 4, I have a point here. From the origin down 3 and over 4, I have a point there for one asymptote. These will be my other points to draw the asymptote. It's easier to do this on your paper than it is to do it on the iPad. Okay, we'll just graph it in blue. So from the vertices, I'll approach the asymptotes. And there we have our graph. Okay, on today's assignment, everything has the center at the origin. This is assignment 14. And it's on page 745. I want you to do 7 through 12 all, and 18 to 24 even. Next class, we'll look at the center at HK.